What is ASP.NET Blazor? Join me on the journey as we explore in detail what Blazor is and how we as application developers can get the very best out of it. I'm Carl Randall from Assemblysoft. Let's get to it. So what is Blazor? Well, it gets its name from both browser and razor, as you can see here from the official documentation, to form a new word, Blazor. It's really a mutation because it would have been Blazor, but the development is moving blazingly fast right now. And if you to look at the repo that the Microsoft team are adding to, the commits that are going in daily, you can really see the amount of effort that's going in order to deliver a fantastic framework. From the documentation here, we can see that Blazor is a web UI framework for building rich, interactive user experiences in C# and Razor, offering the benefits of a single-page application (SPA) framework while keeping all your code and data in .NET. It gives you a modern, component-based architecture for powerful code reuse, first-class development tools, and all the productivity of .NET. Okay, what does that mean in layman terms? In a nutshell, Blazor is a SPA framework. It's new from Microsoft. It means we can actually use C# to create client-side web applications. So, as mentioned, Blazor is a web UI framework. So how does it fit into ASP.NET that we're already using for web application development? Blazor is a feature of ASP.NET, the popular web development framework that extends the .NET developer platform with tools and libraries for building web apps. So Blazor is now a core part of ASP.NET. So it's a first-class citizen. If we have a quick look at the GitHub documentation for .NET and ASP.NET Core, we'll start to see how that comes together. If we look into the source and under components, we can see that in its very recent history, 8 days ago, Blazor has been updated along with all of the other parts of ASP.NET Core that the team are currently working on. If we have a look through here, we can see that we've got some warning suppression that's just taken place quite recently. And I was looking through some code just last week where they were doing JavaScript interop and making that available as part of Blazor WebAssembly. So it really is moving fast. And what's really nice to see is it is a core part of ASP.NET. So from now on, it will be maintained along with the releases of ASP.NET Core. And this really is a game changer. Finally, we've got .NET end to end. Now, as developers, we've become accustomed to full stack development with more platforms and frameworks emerging, particularly with JavaScript on the client and server. It's not uncommon for our back-end logic to reside in a cloud with microservices, serverless or more traditional REST APIs using .NET, and our clients to be written in a framework like Angular or a library such as React, and obviously a whole host of other technologies, permutations. The list and options are shifting constantly. If we look back at the not so distant past for .NET, we can even see the likes of Silverlight, which had the unfortunate limitation of requiring an ActiveX runtime object, which Apple decided flatly not to support. However, the idea was born for being able to run cross-platform, server-side and client-side applications using .NET with reuse of the same .NET components. The problem I'm sure you will come across on a day-to-day with full-stack development is context switching. Bridging between different languages and ecosystems adds cost and complexity. 1 minute we're writing JavaScript or TypeScript and spending time working with the frameworks or library hierarchy and patterns to solve problems, and then you're working in C# and .NET, each with their own package management and configuration issues. Blazor is really set to revolutionize this workflow and enable us to write .NET code, much of which is shared both on the client and server. Using Blazor, you can write responsive web UI components with C# and Razor, share code between the client and the server, and if you need to, call into JavaScript to utilize a JavaScript API or library. You can still do that with JavaScript interop. Interestingly, the first mode to serve this as a thing from Microsoft was actually a first version of what we now refer to as Blazor WebAssembly. Blazor apps can operate in one of two different modes or hosting models. We'll start on the right hand side first, as interestingly, it was actually the first mode to surface as a thing. Chris Dunelm worked on a project called .NET Anywhere, which would be a super compact runtime that could run on a larger set of devices. If we have a quick look at that repo, this was some 8 years ago, as you can see. And although this didn't really make it that big at the time, a lot of excitement was generated as a result. But interestingly, if we jump forward some 6 years to 2018, we find Steve Sanderson picking up .NET Anywhere and mono development with the goal of running it in WebAssembly, as in running .NET in the browser. And so if we go to that project, you can see here that there were still commits going in around 3 years ago into this project, and Steve has done an absolutely fantastic job, and this is really the beginnings of what we know now to be ASP.NET Blazor. So what exactly is it? Client-side Blazor, or Blazor WebAssembly, runs on a technology called WebAssembly. WebAssembly is a binary-based instruction format of a stack-based virtual machine. So, WebAssembly is more of a target. WebAssembly is low-level bytecode and you can compile to it. What this means and why it is so exciting is literally for the first time in web development history, it breaks the mold of JavaScript having complete control over client-side front-end application development. There are multiple languages targeting WebAssembly. C#, aka Blazor, Rust, C++. But how does this actually work? Well, we write our code in C# and that code just gets compiled to DLLs. Then in the browser, Blazor runs on top of the mono.NET runtime, and that is where it gets compiled to WebAssembly. So mono is compiled to WebAssembly. That loads C# DLLs and executes C# code in the browser. Cool or what? Now, there are a few caveats. WebAssembly is very new. It's based on web standards, which is absolutely fantastic. As a result, there are an awful lot of changes and features still to be added. You still need to use JavaScript in order to interact with a lot of JavaScript APIs. For example, geolocation, local storage. What is interesting is you can wrap these JS libraries as NuGet packages and focus purely on C# and .NET. Another more simplified way of thinking of it is that it offers a way to run a high-level programming language in the browser, in a way that only JavaScript has been able to really do effectively up until now, with a goal of running at native speed. WebAssembly is supported by all the latest versions of the major browsers. So let's take a quick look at a Blazor WebAssembly application running in the browser. If we just pull up Visual Studio, as you can see, we've got our different project types. We'll select Blazor app, just continue with all the defaults, and now you can see we're presented with two options, the two hosting models that we discussed earlier. We've got the Blazor Server app, which has been around since .NET Core 3.0, and we've also got this Blazor WebAssembly app, which is in preview currently, set for release next month, but currently you need ASP.NET Core 3.1 in order to see this template light up as part of Visual Studio. We'll create that application now. Let's just increase the size of the environment so we can see that a little bit better. And if we navigate now to the index.html, one of the static resources that's actually included inside the www directory, we can see that we've got standard HTML5 going on here. We've got the HTML element, we've got the head, got our body element, and then inside head we're seeing what we'd normally expect for a typical ASP.NET application. We've got our Bootstrap CSS being included here, and we've also got our own custom CSS included as well. Where it gets a little bit interesting and somewhat different for Blazor is we've actually got this app element, something similar to what you might find in an Angular application or a React application. So this is where our app is going to be bootstrapped and perform the initial load. What's making that happen is this inclusion of this JavaScript at the bottom here, this WebAssembly.js. So let's fire this up and have a look at the application load in terms of web resources. Okay, so now the application is loaded. We've started the Chrome DevTools and hit the network tab so we can see the requests currently taking place. We can see that this request is made to localhost. Now we have a look at the response for that. That's our index.html with our WebAssembly.js JavaScript loading there. We've got the min.css for Bootstrap, the site.css, our custom CSS, and we get to the Blazor WebAssembly, and here's where we start to see the requests being made as part of the initialization of this JavaScript to actually start requesting resources from the server. The first one that we can see here is this blazor.boot.json. We can see this is going over the network and calling this static file. And then the response that comes back from this JSON file is a list of assemblies, resources that are required for our application to run. So the interesting thing to note here initially is that we can see our actual application DLL being requested, and then we can start to see a number of different dependencies as part of ASP.NET Core that we would expect in a traditional web application. I'll just scroll down the list of these, and then on top of that we can actually see that we've got a definition of the runtime requirements as well. As you can see, it's .NET 3.2 preview here, so .NET 3.1 onwards, but this version is currently targeting .NET 3.2. So one other really interesting thing to note while we're just looking at these runtime dependencies is this .NET.wasm request. So if we have a look at that, and this is really where a lot of the magic is actually taking place. So we can see here we're dealing with the actual .NET Mono runtime, which is actually compiled to WASM coming down the pipe. So Blazor is not compiling our app to WASM, it's sending .NET Mono compiled WASM to the client and then sending your .NET Standard Application DLLs unchanged to run within the context of a client-side runtime. The other interesting thing to note is that we have a look at the WebSockets tab. We're not actually seeing any response data coming back down through the pipe in this instance, so we can see that all of this application logic is actually running client-side, so we're not making any round trips at this point. If we initiate this fetch data component here, what we'll start to see in the XHR requests is a return of some sample weather data, which was returned in order to light up this table here. But no SignalR connection required, no WebSocket from the server, just standard web requests going on now to a controller which sits in the back end. Another interesting thing to note is the initial size of the download. I'm currently running this in debug, which is slightly higher than normal, but the average size for an ASP.NET Blazor WebAssembly application is around the late 5, crossing over to 6 meg in transfer. Now we're probably quite likely, as WebAssembly continues to grow, continues to evolve, continues to be supported by the major browsers, we could see a scenario where these runtime components are actually included possibly in the browser, or maybe as an extension as part of an OS install. We'll have to wait and see how that pans out, but it is something that obviously all the browser vendors are going to be keen to tackle, as are those that are targeting WebAssembly as well. So yeah, really interesting space in terms of how this problem will be solved. But interestingly, if we now at this stage perform a refresh of the application and we keep our eye on the network tab, we've still got that request for the JSON in order to compare and ensure that the local cache contains these assemblies. But what's interesting to note is that we're not actually having to download all of those DLLs again. It's just loading a number of standard web resources that are required, because the browser is actually caching these assemblies, which is really reassuring, because it just means the overall transfer here, you can see it's 1.7 kilobytes. So, you know, nothing different really from an ASP.NET Core application in terms of load once that initial load has taken place. If we have a quick look at this getting started guide with ASP.NET Core Blazor, there's a number of things just to note with Visual Studio Code. If you have the .NET Core 3.1 SDK already installed, then you're good to go. That's the same way that Visual Studio 2019 is including the preview templates. But if you're using Visual Studio Code and you don't currently have the .NET Core 3.1 SDK installed, you can actually install the Blazor WebAssembly preview template yourself. It's just a NuGet package. It doesn't form part of the application that you're going to develop, but it does enable you to light up the scaffolding options within Visual Studio Code using the command line interface. Now, if you're still using .NET Core 3.0, what you'll find here is that you can still do a .NET New Blazor in order to scaffold a Blazor Server application, because that was the only one that was released at that time. But as we're so close now to Blazor WASM making it into production, there is actually a distinction: Blazor Server and Blazor WASM. So there's been an upgrade in terms of the naming that's used now for Blazor Server. It's specifically Blazor Server, and we've got a Blazor WASM, and we'll demo that in just a second. So we can just demo this briefly. If we just call up .NET New command and just have a quick look at the help available in terms of the templating options, what we'll start to see are template options starting to appear. So we've got Blazor Server showing up here, but we don't have a Blazor WebAssembly template that we can use to scaffold our application. So if we just go back to the docs briefly, we'll notice that we can consume this templating package. Let's just copy that in and install it. And you'll notice obviously this is a preview package. But what's interesting now as a result of installing that is we've now had this additional template installed, which is Blazor WebAssembly. So we could do a .NET New Blazor WASM, standing for WebAssembly, and what we'll do is we'll just send that to an output directory in this current location, and we'll just call it Blazor WA for now. And you can see now it's doing the restore, it's generating the project, and the restore has succeeded. So if we now go into our Blazor WASM directory, launch Visual Studio Code. Okay, looks like we don't have it installed on this machine. Let's install that now. We're presented with our getting started guide. We're not going to need that just yet. Let's run the Visual Studio Code installer. So let's restart PowerShell, and then we should be able to launch Visual Studio Code. Now we can see it's opened up the newly scaffolded application. we'll see something familiar as to the way this project is actually laid out. And what we can do is just fire up a new terminal quickly just to see this. We'll perform a very quick .NET run and open up a browser window. And we can see there that our application has actually loaded. Well, we are really starting to understand the journey with Blazor WebAssembly. When we look back at all the projects and all of the technologies that have brought us to where we are, we can think of the modern support of WebAssembly. And if we look back, we can think of the Mono project, the Xamarin project. We can think of all the work that has been done with ASP.NET Core, with .NET Core, and as a result of that, .NET Standard, which is able to run on WebAssembly. And this is really set to pave the way for a great user experience as we process much of our logic on the client and then reach out to the server to consume services and to grab data. It really is an exciting time to be a web application developer utilizing Blazor WebAssembly. So let's turn our attention to the server hosting model, Blazor Server. Blazor Server apps run your components on the server on top of .NET Core. In fact, it's the full .NET Core runtime. So anything that you would want to do in terms of accessing databases, calling out to APIs, you've got the full stack at your disposal because all of that code is running server-side. As a result of a lot of the hard work that's been performed with WebAssembly, there was some seriously good patterns utilizing SignalR and WebSockets. So right now, as of ASP.NET Core 3.0, Blazor is production ready. With the Blazor server hosting model, the app is executed on the server from within an ASP.NET Core app. UI updates, event handling and JavaScript calls are handled over a SignalR connection. If you wanted to learn just a little bit more about SignalR, which sits on top of a WebSocket typically for Blazor, I've got a project here which was a DevOps task runner which utilizes SignalR in order to send UI events to the browser and to the user. If we have a quick look into the code, you'll see inside here there's a hubs, which is a typical pattern for SignalR, and in here we've got a broadcast messenger, which is just a very simple implementation of a SignalR message hub. So you can see here it's doing a broadcast messages in groups, and we've also got this broadcast messages and then sending that message to the client there. So have a little look at that if you're interested. So as we already highlighted, Blazor server apps run your components on the server on top of .NET Core. Blazor Server then sets up a real-time connection with the browser, typically over a WebSocket using SignalR. Events that happen in the browser are sent to the server and handled by your components, which then render. Blazor then keeps track of any changes made to the UI using a sophisticated diffing algorithm. Any changes are then sent back down to the browser and applied to the DOM. Blazor server apps are a very thin client and can run great on low bandwidth devices and in older browsers. .NET code runs on a full .NET Core runtime, so normal .NET features like .NET debugging just work. It can also simplify the architecture by eliminating the need to stand up additional APIs and endpoints. All the code stays on the server. So as the app grows, the application size doesn't increase. Blazor Server has been supported since ASP.NET Core 3.0, so ready for production. Blazor code executing on the server has the flexibility to do anything you would normally do on the server, such as connecting directly to a database. Okay, so let's have a quick demo of a Blazor Server application from a resource usage perspective. If we fire up Visual Studio, we can see here we've got an application. It's got a number of Razor components. It's got our index Razor, and we've got this connect4.razor component as well. We won't go into any detail in this session on the actual components, but join me in the next session where we do a deep dive into Razor components. If we just select the host.cs HTML, similar to what we do in any Razor syntaxed ASP.NET Core application, we can see here that we've got our familiar head section and we've got our style sheet inclusion going on here. We've got our body section and we've got two new things to think about. So we've got our app element, which is the bootstrapper, which is going to load our Blazor application, our Blazor Server application. And then we've got the inclusion of a script here, our JavaScript, which is _framework blazor.server.js. So let's run this application and take a quick look. So we can see here the application has loaded. Let's bring up the Chrome DevTools. I'm on Windows, so I hit F12. We can see here in the console that there's been a normalizing with Blazor to this server address, and then we can see an indication of a WebSocket that's actually been established, this WSS protocol here with this unique ID. If we turn our attention to the network tab, we can see here, as we saw in the .cs HTML file, a request that's made for the initial page. We look at the response, we'll start to see some familiar items that we'd seen in the .cs HTML. We've got our head with the CSS, we've got the body here, but what's interesting is when we start to look into the app component now, it's actually filled with a number of elements. We've got here a sidebar and a collapsible menu, and then we've got this main section which contains our child content, this hello world boilerplate code, and at the bottom here we see our blazor.server.js, which was responsible for initiating the WebSocket. So these resources that we see here are completely familiar. We've got that negotiate request which is taking place, and we can see here that unique connection ID along with a connection token as well, and the fact that it's actually using WebSockets over this text binary format. If we have a look at the actual WebSocket itself, we'll see that it actually contains a set of messages which are occurring, and we can see if we scroll right to the top this new Blazor Pack protocol. After the initial message is sent, we can see a response which is just a polling response here. Then there's a binary message which is actually sent from the client to the server, which indicates this initial endpoint to load, and then we can actually see a response coming back down the wire over this SignalR message sitting on top of this WebSocket, which is actually starting to route now to our body element, along with providing this initial set of markup that's required in order to render this initial state and this child component. After that, a message is sent back to say the render is complete, some more data being received by the application, another JS begin invoke message being set up here, which is, as it says here, is enabling navigation interception. So we're ready now to start actually selecting items and navigating the UI, and then we can see we're pretty much back to this very simple 3-byte message which occurs to keep that WebSocket connection alive. So at this point we've rendered the application, and the only thing really going on now in terms of server interaction are these small 3-byte negotiation messages to keep this connection alive. And what's quite interesting really just overall at this point is that the largest transfer of data that we've actually received in order to render this boilerplate Razor component is 3.1 kilobytes. That was the largest bit of data that was actually received down the wire, and this was just to set up this initial rendering here. Everything else has really been quite efficient in terms of transport data. So we'll clear these current messages now, and we'll focus on this navigation menu, and we'll initiate the next Razor component, which is our simple Connect4 game, which is an open source component. But we'll just initiate that menu. You can see here from the UI that what we're presented with is this game board, which enables us to play a game of Connect4. It's currently saying it's Red's turn, so we'll just select an item, and you can see here that it's now Yellow's turn. So let's select again, and then back to red, yellow, red, yellow, red, and then I'll leave this end state just for a moment. We'll just inspect the messages that have occurred, and then we'll come back to the final game state. So if we look back to where we started, we were in the polling, then we actually selected a menu item. So this dispatch browser event was sent, this message, the SignalR message, and you can see here that it's effectively some event handling data, which is capturing our X and Y mouse coordinates and any button control keys that we may have selected as well. And then the server responds with a batch render yet again, and the on render is actually complete. So this was the point where we actually selected the menu and it dropped down. Then we can see that we actually perform a click event here. So we've actually clicked and we want some detail, and the actual Razor component menu item that we've selected, and as a result the Razor component that would need to render server side is actually this Connect4 root. So server side, this Connect4 Razor component has been instantiated, the class has been instantiated, and the rendering has actually taken place. If we scroll down a little bit further, the response message that comes back over the SignalR connection is to perform this js.render batch again, and it's performing this class.collapse. As you can see, a message is sent back again that the render is completed, and then the actual Razor component data is received for the first time, and the game board itself is actually rendered. You can see here we've got this H1, we've got a number of elements here which show some variables and the states that the data is currently in on render. And then if we select the next item, which is sent back to the server, we can see that it's render complete. So we can see that the next message that is received from the server is to set this menu item to active in this burger menu that we can see here. Finally, this on render completed event is sent back to the server, and then we're back to this polling that occurs that we saw previously. Then another message is sent to indicate that we've actually clicked the game board itself. So we're back to this dispatch browser event again, really starting to see some similar patterns emerging each time that we interact with our UI and the way that the Blazor server application is sending messages back to the server in order to perform the server-side rendering here. So we've sent some mouse events, there was a click as well, and we can see that this was the initial game board event, and then the server sends back a message. And then we can see this yellow.onClick, which indicates that it's Yellow's turn at the beginning there. We've got this red, which possibly indicates that we're setting a CSS class, but you can see how the transfer of data between the button clicks is happening with this dispatch event back and forwards until we get to a situation where we are at the moment, where we've gone back and forwards for each game piece. We're then back to polling, as I've been speaking here, nothing else going on. And if I move my mouse over the game board, it's not been written to respond to any hover events, so we're not getting any messages there. It's simply waiting for another button click with the mouse coordinates in order to set the next state in the game. So I'm just going to clear those messages again, and if I now finish off the game, it's yellow's turn, and I'll complete this connect for row. And as you can see, we get a number of messages. We've also enabled this reset button now. We've got the message that yellow wins. So let's just inspect that just briefly in the WebSocket messages. We had the polling, the last polling message that was received, and then if we look in these binary messages that were sent, again, it was the X and Y coordinates on the click event for the final piece that was initiated, dispatched back to the server, and then the server responded with this JS render batch. Incidentally, if we started getting quite chatty by clicking quite quickly on the game board, this JS render batch would contain multiple items to update. In this particular case, we've been quite slow and for this demonstration to really show the individual messages. But we can see here that in the last response that was sent back as part of this WebSocket message, the SignalR message sitting over the top of WebSockets, that yellow wins. And we can see there that we're setting some CSS class, this button success, for example, which is showing this reset button. And we can see that yellow wins the game. So after that, we finish off by completing the on render, sending that back to the server, and the server then continues to simply poll to keep that connection alive, awaiting the next event. So hopefully this has given you a really nice flavour of the smarts that are taking place in terms of the UI events that are being sent back to the server, and the complex diffing algorithm that is determining these small deltas that, based on the actual changed elements, can be sent back to the client, passed to the Blazor render tree, a form of shadow DOM, and then applied finally to the browser DOM extremely efficiently. If we have a quick look now at the Blazor docs, we can start to see some of the benefits that we've actually highlighted. So we've mentioned this interactive web UI with C#, which enables us to compose reusable components. We can run on WebAssembly, as we've highlighted with the different hosting models, and we can also run on the server. As is pointed out here, Blazor uses open web standards without plugins or code transpilation. So we're not compiling at the last minute into JavaScript here. We're actually running C# in the browser. We can share code and libraries, which is fantastic. It means we're going to get some genuine reuse. Incidentally, as a side note, the only limitation here is that we write our components to support .NET Standard. As long as we do that, then any applications that we've currently got can very easily be ported to Blazor existing applications in order to benefit from all of these features and utilize that code both back end and front end. We've also mentioned JavaScript interop. We can package our JavaScript calls into a very nice pattern which has been developed, which enables us to call C# code from JavaScript and JavaScript from C# code, and we can wrap all that into a NuGet package. And then, as we've pointed out before, we're just dealing with C#, both server side and client side. We've got great tooling, obviously Visual Studio, Visual Studio Code. What's also interesting is this UI component ecosystem. So you've got a number of companies realizing what kind of potential these components are going to have, these reusable Razor components, and you've got the likes of some mentioned here, and there are others. You can also write your own. So a really exciting time for Blazor development. If we have a look at the documentation, we can see, as we'd expect, it to appear under the ASP.NET Core 3.1 docs. And typically we'd come in to look at some documentation for Razor pages or MVC, and now we can see this section for Blazor. And these guides are absolutely first class. I would definitely recommend going through them end to end. You can see that they're being updated regularly. This one was just towards the end of March, so there's an awful lot of effort going in to ensure that the adoption is actually a really smooth process, and particularly if you're using ASP.NET already, the transition is extremely smooth. So if you're as excited as we are right now about Blazor web application development, then subscribe to the channel. Hit the bell icon so that you can receive notifications when we upload new videos. Thanks so much for joining us today, and we look forward to seeing you in the next session.